Here we have a SAT math problem. Okay, let's go to the question. A 30, 60, 90 triangle has a perimeter of 18 positive 6 times square root of 3 inches. What is the triangle's area in square inches? Round your answer to the nearest hundredth of a square inch. Okay, first let me draw a 30, 60, 90 triangle. Here I have drawn 30, 60, 90 right triangle. That is the interior angles are 30 degrees, 60 degrees and right angle that is 90 degrees. Okay, in 30, 60, 90 triangle, we have to consider the side which is opposite to the smallest interior angle measure, that is 30 degrees. So this is a side opposite to this smallest interior angle. Okay, now we have to consider this is the shortest leg of this triangle, and usually we assume x as the length of the shortest leg. Now, to get the length of the next longer leg that is opposite to the interior angle 60 degrees, what we have to do is we have to multiply the length of the shortest leg x by square root of 3. So, the length of this leg is x times square root of 3. And this is the hypotenuse because it is opposite to the right angle. Now, to get the length of the hypotenuse, we have to multiply the length of the shortest leg x by 2, then we get 2x. Okay, here I got the lengths of all the three sides of this triangle in terms of x. Okay, now if I want to get perimeter of this triangle, what should I do? I have to add the lengths of all the three sides. That is x positive 2x positive x times square root of 3. So this expression represents the perimeter of this triangle. But already we have perimeter in the question. That is 18 positive 6 times square root of 3. So this one and this one, both of them represent the same stuff. That is the perimeter of the triangle. So we can equate them. That is equals to 18 positive 6 times square root of 3. Now we have to solve for x in this equation. When I combine this x and 2x, I am getting 3x. That is 3x positive x times square root of 3 equals to 18 positive 6 times square root of 3. Okay, here we can factor x out from these two terms. When I factor x out, then I'm getting 3 positive square root of 3 over here. And on the right side, the greatest common divisor for this one and this one is 6. So we can factor 6 out. Okay, if 6 is factored out, to get the stuff inside the parenthesis, we have to divide both the terms by the one I factor out. Okay, when I divide this 18 by 6, I am getting 3. When I divide this 6 square root of 3 by this 6, I am getting square root of 3. Okay, now let me divide both sides of this equation by 3 positive square root of 3. Let me do it. When I do so, this one will cancel out. Here, this one will cancel out. I am getting x equals to 6. Okay, here I got the value of x, that is x equals to 6. When I plug in x equals to 6 over here, it will become 6 square root of 3. And this side will have length 6 and the length of the hypotenuse will be 2 times 6, that is 12. Okay, here I got the lengths of all the three sides of the triangle over here. Okay, in any right triangle, apart from the hypotenuse, the remaining two legs, what we can do is we can consider one of the legs as a base and the other leg as a height. Okay, here we can consider this leg as the base of the triangle and this leg as the height of the triangle. Okay, we know the formula for area of a triangle. Okay, let me write the stuff over here. Area of a triangle is equal to, the formula is the base times height divided by 2. Okay, here the base of the triangle is 6 times square root of 3 and the height of the triangle is 6. Okay, let me plug in divided by 2. Okay, here 2 goes into 2 1 times and 2 goes into 6 3 times. Okay, when I multiply 3 and 6 times square root of 3, I am getting 18 times square root of 3. Okay, now using calculator, we can get the value of this one. Then I'm getting 31.176 and it keeps going. According to the instruction we have over here, we have to round our answer to the nearest hundredth. So we have to round this value to the nearest hundredth. Okay, let me do it. Then I'm getting 31.18. Therefore, the area of the triangle is about 31.18 inches square.